today we are going to talk about numbers. Wait, what's the biggest number? I know, that's not what we're going to talk about. I've already done that, if you want to see that video. Oh yeah, I just forgot to say, welcome to Julian Stories. Okay, today we're going to talk about infinity. What's really is to talk about infinity? It's just infinite. Well, there are things above infinity. Huh? That can't be real. No, yes it can. Infinite can't be subtracted or anything, but there are things above it. People usually think of infinity plus infinity is infinity, but there are some paradoxes to infinity. Take the Achilles paradox. Achilles, very quick, has a race against the tortoise, who's very slow. Achilles gives the tortoise a head start, but he runs twice as fast as the tortoise. So he should still win, right? But Zeno showed that, mathematically, Achilles could only ever catch up by running an infinite number of distances. What the? That's because imagine Achilles gives the tortoise a head start, but then he runs twice as fast as the tortoise. He should be able to catch up, but he never will be. Because think about it. When he runs twice as fast, the distance will lower to 1 out of 2. And then he keeps doing it. 1 out of 4, 1 out of 8, 1 out of 16, 1 out of 32, 1 out of... it keeps going. So that can go an infinite number of times. And that can be shown by using the super task that I call. If you draw one line and then draw another line, the fraction of the size and the fraction of the distance of each last line, you can actually fit an infinite number of lines in a finite space. And it's time for me to explain the cardinality of a set. The cardinality of a cardinal number is like 4 apples, then 20 flags, 42 oranges. However, this is different from infinity. If we draw infinite lines, what's the cardinality of the lines? It can't be one into cardinals, because that could just mean +1. Instead, we've invented a new sort of infinity we call for this, Aleph Null. Aleph is the first letter of the Hebrew alphabet, and Aleph Null is the first smallest infinity. It's the cardinality of the set of cardinals. But hang on a second. What happens if I draw this? Now how many lines are there? Aleph Null +1? No. Ordinals aren't like cardinals. They can't be +2. This cardinality of the set is still Aleph Null. Because think about it. You could draw 0 on the first line, then 1, 2, 3, 4, blah, 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 blah. Now I could draw another one. 0, 1, 2, 3, 4, blah, 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 blah. Now I could even go 2, 3, 4. I can even add another set of Aleph Null lines and still have the same positive. We could have every even number and every odd number. There's still Aleph Null. But hang on a second. What if, instead of matching them 1 to 1, we did the order of them? So let's go back to having only one line and do this. 0, 1, 2, 3, 4, blah, 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 blah. Now, what's this one? It can't be... we have to invent a new infinity for this one. We have to have a set that goes after the cardinals. And we have the perfect one, ordinal numbers. The first transfinite ordinal is omega, the Greek capital letter omega. Well, what if I draw another line? Yep, so you guessed it, that is omega +1. We can keep going. If you came omega place in a race, then that means infinite number of people finished the race, and then you did. Incredibly slow, right? So you can keep going, omega +2, omega +3, blah, 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 blah. But, if I draw another line like this, what happens? Is this another one? No. we have to invent a whole new sort of infinity to do that. And then that can be called epsilon. Epsilon plus 1, epsilon, and then it comes more Greek letters that I forgot. Blah, 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 blah. But we can keep going for infinite number of times, which means blah, 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 there has to be something after all these. It's like an infinity inside an infinity that you can never get to, no matter how much lines you drew or how much sets you had. This, behold, is an inaccessible cardinal. Inaccessible cardinals, don't get tricked by their names. They are not cardinals. They are ordinals. Well, sort of ordinals. They cannot be reached by any ordinal. And like an infinity inside an infinity, there are multiple of them, and there are ones that are greater than others. But I won't go into that much here because I'll make another video for that. Probably not. Because words are just inaccessible. It's a bit like the ill-identified numbers in the cardinals I explained once. So anyway, bye. Thanks for watching.